Bismillahirrahmanirrahim. Dear students, we are doing the chapter number 24, grade 12. Grade 12, last chapter 24, lecture number 69. And the topic is mass spectrometry. The last topic we are doing spectroscopy. The mass spectrometry. The mass spectrometry is an instrument which turns atoms and molecules into ions and measure their mass. So it means that we will calculate the mass of the atoms. Actually, in this technique, we will use to calculate the mass of isotopes present in atom, just like carbon, just like neon, just like hydrogen. Masses of isotopes and their abundance percentage, both by using graph peaks. The computer will form a peaks graph. Atomic masses versus abundance percentage. So we will calculate the masses of isotopes of elements with their abundance is called mass spectrophotometry or mass spectroscopy. In 1909, Aston first 1919, Aston, he invented the mass spectrophotometer or only mass spectrometer. This gave chemists a reliable and also accurate method of comparing the relative atomic masses of atoms. At one time, the relative masses of atoms were known as atomic weights, but nowadays we refer to them as relative atomic masses. We call them relative atomic masses to compare the atomic masses of the elements with standard atomic mass, which was first taken hydrogen, now it is taken as a carbon, which has the exact 12.0000 atomic mass in atom AMU. So we compare all the atomic masses with standard atomic mass of carbon. That's why we call relative atomic masses. Dear students, mass spectrometry, this is the analytical procedure, analytical technique which involves the first we are going to change these atoms into gaseous state. Production of gaseous under the substance element investigation. Now they separate, because I told you hydrogen, it has 3 isotopes, neon also maybe it has 2 or 3 isotopes, argon also maybe. So these isotopes can be separated by mass to charge value. This is important. Mass to charge value. Mass of isotope and charge of isotope. Mass to charge value and the measurement of their relative abundance I told you in these ions. In this technique, no absorption of light is involved. No light is involved here. This is why it is commonly called spectrometry. It is no light is absorbed or evolved, no That is why this is commonly called spectrometry instead of spectroscopy. We call them spectrometry, not spectroscopy. I told you that mass spectrometry, not mass spectroscopy. It is called mass spectrometry because the ultimate result is obtained in the form of spectrum, as in the case of other spectroscopic techniques. So this is the general introduction about the mass spectrometry. We have to calculate the masses of the isotopes and their abundance. Basic principle of this technique is organic molecule under high vacuum is bombarded with an electron of energy greater than the ionization energy of the molecule. Must be greater than the ionization energy of the molecule, then changes into gaseous state, then changes into ions. First solid, it may be present into solid, change into gas. If the gas is okay, then ionization taking place. So most of the organic compounds around 10 electron volt are 946 kilojoules per mole. 10 electron volts or 964 kilojoules per mole ionization energy. As a result of this, one of the electron of the molecule is dislodged and singly charged molecular ion is produced. The molecular ion which is produced in this primary process is a radical cation or cation. It has unpaired electron and positive charge. Unpaired electron. So this is the metal ion. Electron. Molecular ion. This is the charge. Like this one. Then the central is in the vapor state usually subjected to beam of electron about 70 electron volts energy. These highly energetic electrons not only ionize the organic molecule but also impart large amount of energy to the molecular ions. The molecular ions generally dissociate into fragments are called fragment ions. Fragment ions. They are going to be changed into fragment ions. So this is the M1 fragment plus M2 fragment or like this one. May be formed in this form. The positively charged ions are separated by deflection in variable magnetic field. Every positive ions which have different masses. I told you the isotopes, they have a variable magnetic field. The ions are directed into an analyzer tube surrounded by the powerful magnetic. The magnetic deflect the ions from their original path, causing them to adopt a circular path, the radius of which depends upon the mass to charge value. Mass to charge value. M over E value. So the ion beam of particular mass to charge value can be selectively focused through the narrow slit onto an ion collector where it is generated current proportional to the relative abundance percentage. Relative abundance. of the ion in the beam, which is recorded in the form of spectrum by computer. The mass spectrum, in fact, a plot of relative intensity of ions against their dimensionless mass to charge value. The doubly charged ions are deflected much more than the singly charged ions, heavier means, and appear in the mass spectrometer at half of the charged mass to charge value, means 2. If there are double, then m over 2e, or you can write z atomic, this charge, z is a charge, maybe z is written, atomic number positive of singly charged ions. Same as, for example, doubly charged ions of mass 90 gives rise back to the m over v, means m over divided by 245 means. Dear students, there is a simple example for you to understand how the mass spectrometer works. What is the basic idea according to the in daily life simple example? The basic idea of mass spectrometer can be demonstrated using apparatus. You can see the figure, page number 356. Wooden balls. You have wooden balls with different sizes. Wooden balls but different sizes. Small, some biggest sizes, small. Different sizes but identical iron core. Iron is embedded in the wooden ball. The size of that iron will be same, identical. Size of the iron core is same, but the size of whole ball, wooden ball, is different. This is you have to understand. So there is a slide. Here is a slide, and you can form down here boxes. You have here boxes down. Wooden balls of different sizes but with identical iron core, roll down, sloping. Here roll down. You have to roll down here one by one. So you can observe, students, that at the bottom of the slope, powerful magnetic attacks the iron. You see the magnet is here. In the end of there is a magnet. And down there is a collector here. Different boxes are given here. Rolling the ball, which is made up of this wooden, and size of the wooden ball different, iron will be same. So when it crosses and it's go down, what do you find? As the balls have identical iron core, they are all attracted equally. They are all attracted equally by the magnet because size of iron core is same. But size of balls are different. Size of balls are different, but the smaller balls are lighter and therefore deflected the most. Smaller ball are lighter, their deflection is more. Increasing deflection, you can see in the diagram. Collecting compartments, there are different compartments are there. So small ball can be deflected more and heavier ball, or we can say larger ball, can be deflected less. So it means that when you are going to use the mass spectrometer, the atoms which have a small atomic mass deflected first, and the isotopes which have more atomic mass, heavier, they deflected later. This is the principle. Second, the balls collect in different compartments depending upon their mass. I told you, mass over E. All balls of the same mass collect in the same compartment. If we have a same sizes of the balls and same iron core, they collect same. But wooden balls, they have different sizes. The iron core is same magnet, same iron. So that's why the smaller size of ball is going to be more deflected as compared to the heavier ball. So using this simple apparatus, it is possible to separate the different size balls according to their mass and find the relative number of each percent. So we will be able to calculate the relative abundance of the atomic mass of the isotope and also mass of the isotopes. That's why smaller, or we can say lighter isotopes can collect first, and heavier isotopes mass collect later. So this is the basic principle which is given here. The page number 357. A real mass spectrometer works in a simple or similar fashion. Already I told you, with this simple technique we have to use this one. It separates atoms according to their masses. Formula I told you, mass to charge value, m over E or m over Z. So before the atoms can be deflected and separated, they must be converted into their positive ions. Already I told you, first the sample should be vaporized, then it is going to be ionized. After vaporize the sample, then ionization taking place, positive charge is created, then ions or positive ions obtained from the vapors. The acceleration, the positive ions are accelerated by the electric field. Then deflection of ions are deflected according to their mass to charge values. I told you the ions or isotopes which have a lighter can be deflected first and the heavier can be deflected later. So deduction of ions are deducted and record as the weight. So you have the original diagram of mass spectrometer. You are seeing on the top vaporized sample, then ionizing chamber, then electron gun, positive and negative charge are given here, then accelerating the electric field, then there is a powerful magnetic is here, then you can see that heavier particles are deflected later and the lighter particles are going to be deflected first, and then there the vacuum and the pass through the vacuum, and there detector, it detects and sends the signal to the computer, and there the amplifier and recorder computer, and you can form the different peaks and the different abundance. So dear students, this is the mass spectrometer. So here there is a quick quiz. Look closely, figure 24.13. How many different ions are deflected? You can see 3. One has a relative abundance, very high, about 95%, and atomic mass is 24. Then there is a short 25 atomic mass and 26 atomic mass with less percentage. So this is for the magnesium. Magnesium has atomic mass. This is the group number 2 elements, and it never changed about the 24. You can see long peak, 99.5 or 8% of the 24. So mostly we write 24. Means in these 3 isotopes, 24, 25, 26, the 25% is not more than 10 and 26 not more than 10. But the percentage of 24 is about 90 or more. So that's why this mixture contains more 24 magnesium. This is according spectrometry. So we can calculate the atomic masses of relative abundance of their isotopes, students. So this is now finished. We completed the whole spectrometer and spectroscopy complete topic. Related exercise questions and quick quizzes are included. Society, science and technology of all chapters not included. The paper will be curriculum based, not book based. So general question will be asked according to these topics. So we completed here the syllabus. So dear students, you must revise at your home according to the reduced syllabus. You should have this paper. All the chapters there are mentioned here. So I will discuss your coordinator. Then if you need some revision, all recorded lectures are available here. But if you see, then I will see what happens. And you have to solve all exercises questions also. If you see the objective questions, question number 1, which of the following does not involve an electromagnetic radiation? Mass spectrometry, no radiation. Which region of the electromagnetic spectrum is involved in electronic excitation? Both of these means ultraviolet and visible. Which of the following technique is different from other as regards the basic principle? Electronic spectroscopy. Which of the following is used as source of visible radiation? Tungsten filament. What is the wavelength range of ordinary infrared region? 2.5 to 16 micrometer. The position of an infrared absorption band is commonly expressed by wave number. B option. Which of the following is not used as source of infrared radiation? Tungsten filament. Which region of electromagnetic spectrum is involved in mass spectrometry? Visible. Mass spectrometry is an analytical technique which involves separation of the gaseous ions. All of these, production of gaseous ions from the sample. Yes, all these options are correct. Mass spectrometry can be used to determine masses of the element, molecular weights. Which are the following species detected by in the mass spectrometer? Positive charge ions species. Which are the following species produced in the ionization chamber of the mass spectrometry? Positive charge species. A option. Which kind of information about the positive charge species obtained from the mass spectrometer? Relative abundance. What kind of sample can be studied in the mass spectrometer? A gas. Solid must be converted into gas, then it can be ionized. Near ultraviolet region of these electromagnetic spectrum generally lies in between 10 to 200 nanometers. So these questions you have to solve according to your knowledge, and exercises questions must solve them. So we end this. So inshallah I will see what happened. If I'm going to revise the chapter, okay, no problem. So thank you very much. Work hard. Examinations are going to be held. I don't know the situation in Pakistan. We have to go look for good, not for bad. So look for good. Always think about the positive, not negative. So inshallah we will see what happens. So you have to prepare yourself according to the reduced syllabus. Thank you very much.